Hello, I am Professor N.B. Hulle from G.H. Raisoni Institute of Engineering and Technology, and in this video we will try to solve problems based on the superposition theorem. Here, to be start with, I have considered one of the simple problem in the superposition theorem, and we will try to find out current in the 20 ohm resistance. Now here this RL in our case is a 20 ohm resistance, which is equal to 20 ohm. Now here, as per the statement of the superposition theorem, we have to calculate current in the 20 ohm resistance, considering each source at a time. Now here, in this case, we have the two sources. That's why we need to consider the two cases. Now here, I will start with the case number 1. That is first case. In first case, we will consider 100 volt source, and by that time 60 volt source will be replaced by its internal resistance. It will be something like this. And here I am using the reduction technique. There are other techniques that are also available, in which I will discuss maybe in the next video, in which we can use the mesh analysis for the calculation of the currents or currents for the case 1 and case 2, or maybe any other methods also. Now here this is 15 ohm and this 60 volt source, here it is replaced by its internal resistance, which is 0, because voltage source has a 0 internal resistance and current source has a infinite internal resistance, theoretically infinite. Here in this case we will consider the theoretical value, that is 5 ohm. It is 100 ohm. Now we will use the reduction technique again, and we will try to minimize this figure. Its next part will be something like this. Here is a battery again, this resistance. I will reduce one at a time. I will not do so many stages at a single time. Now here it will be something like this. Here it is 15, this 10 plus 15, which is 25. These two resistances are in series. Here this will be the 20, this will be the 5, and here it is the 15 ohm, and its value of the voltage, it is 100 volt. Now next, these two resistances are in parallel combination. Its reduction will be something like this. Now here in this case, 100 volt source will remain as it is. Here it is 5 ohm. This resistance will be of the 15 ohm. And these two resistances are replaced by the single resistance having its parallel combination. I will call it as RP1. This is equal to, here it is 15 ohm. This will be 5 ohm with plus and minus terminal. Now here I will work out the calculations, in which 20 into 25 divided by 45, which is equal to 11.11. This value is 11.11. Now here we are in a position to calculate its total current I. Here in this case I will mark the polarities. It is necessary to mark the polarities. Here we are aware of this total current, which is I1 for the first case. I will call this as I1, which is equal to total current for the first case is equal to total voltage, which is 100, divided by total resistance, which is 5 plus 15 plus 11.11, which is equal to 31.11. Which is equal to, if I am finding its value, that is 100 divided by 31.11, which is equal to, in this case, it is 3.21 amperes is the value of the current. 2.31 amperes is the value of the current in this case. Now here, we know the total current. We know the total current from the battery. Total current from the battery. I will show the respective. Here, in this case, this current is known, which is current I1 from the battery. We are interested in the calculation of the current in the 20 ohm resistance. In this current we are interested. I will call it as IL1, that is load current for the first case. Where will be the IL1? Here will be the IL1. And so on. Now here, if we are finding the IL1, I will use the current division rule. Now here, current in this branch is known. Current in this branch is known. We have the two parallel branches, and current division rule is applicable to only two parallel branches. Now here, total current is 3.21 into resistance of the opposite branch. Here we are interested to calculate current. Here this opposite branch will be this, that is 25, divided by resistance of both branches, that is 20 plus 25, which is nothing but 45. If we are working these calculations here, this will be 3.21 into, that is 25, which is equal to, divided by its value is 45, which is nothing but 1.78 amperes, which is 1.78 amperes. It is 1.78 amperes. Now look at the direction. Here, the direction of this current is downward. It is downward. That's why I will mention here this current is downward, because finally we are interested to find out the algebraic summation of summation with sign or summation with polarity. Now here we have calculated its current for the case number 1. We will repeat the similar procedure for the case number 2. I will use this part here. Here it is case number 2. In the second case, we will consider, this is case 2. In second case, we will consider the source 2, which is 60 volt source. And by that time, 100 volt source is replaced by its internal resistance. This figure will be something like this. Here it will be, this is 10, this will be the 15, and here it is 60. This is 60 volt. Here it is 15 ohm. This is 10 ohm. This is the load, which is 20 ohm. Here it is 15 ohm. Last resistance is a 5. Now we will use the reduction technique again. We will reduce the network. Here 5 ohm is in series with the 15 ohm. Means this next figure will be something like this. Here is one resistance. This is the second. Here is the source, 60 volt, 15 ohm. This is 10 ohm. Here this resistance is of the 20 ohm. Here, and this series combination will be 20 ohm. This is. Now what is our aim? Our target is to minimize this particular figure into the single loop. If we are finding its parallel combination, now look at here. 20 is parallel with the 20, means 20 into 20, which is equal to divided by 40, because R1 into R2 divided by R1 plus R2, its value is 10. This here, in this case, if we are working on this calculation, its figure is something like this. Here. Something like this. This is 15 ohm, 60 volt, 10 ohm. Here 20 is a parallel to the 20, that is 10 ohm. Now here in this case we have is total current with us. I will show somewhere here. This loop current or this mesh current or current in the source. The current in the source for case 2 we will name it as I2. And here this I2 is equal to total voltage divided by total resistance. Total resistance is 15 plus 10 plus this 10 means it is 20, 30, 35. This is 60 divided by 35. This I2 will be, it is 60 divided by 35. This is I2 will be 1.71 amperes, which is 1.71 amperes total current. Now if we know the total current here, then we can find out where is the current is known. Current from the supply is known, current from the battery is known, which is something like this. This is I2. We are interested in this current in, I will call it as IL2. And here, if we are finding the current IL2, which is equal to, here current in this branch is known, current in this branch is known. These are the two parallel branches. We are interested to calculate current in this 20 ohm resistance. That's why the equation will be total current 1.71 into resistance of the opposite branch 20, that is this 20, divided by resistance of both branches, that is 20 plus 20, which is equal to, here in this case current is something 0.857 amperes, which is 0.85 amperes. And in this case again, its direction is downward. Its direction is downward. Now we are in a position to apply the superposition principle. Now how is the superposition principle? Current flowing through the load resistance IL, which is the algebraic summation of the currents, that is IL1 plus IL2. Why I have taken this sign as a plus? Because in this case, look at the directions of the currents. In this case, this IL1 or current flowing through the load resistance due to the source 1, it is downward. Similarly, IL2 is also downward. Its direction of the both currents are same. That's why it is IL1 plus IL2, which is very same as 1.78 plus its other current, which is 0.85, which is equal to 1.78 plus 0.85. 1.78 plus 0.85, which is equal to, that is 2.63 amperes. This 2.63 amperes is the current flowing through the load resistance as per the superposition principle or as per the superposition theorem. Now here, this is about how to solve the sums based on the superposition principle. That's it for this particular video. Thank you.